Hello and welcome to another video. In this problem, we're going to be working on sort vowels in a string. And in the problem, you're given a zero index string and you want to permute s to get a new string such that all consonants remain in their original places and all the vowels must be sorted in non-decreasing order of their ASCII values. More formally, all these things. I'll explain it in a second. And here are the vowels, and they can be uppercase or lowercase. So you can have uppercase and lowercase vowels and consonants. And so in this first example, the consonants stay in the same place and the vowels get ordered in the order of E, O, E, E because, and we'll take a look at this real quickly. So here's an ASCII chart. ASCII chart is basically the numerical conversion of a number to some, or to of a character to some number. And so if we take a look, the uppercase characters have smaller values. So here's the ASCII values, like A has a value of 65, this A has a value of 97. So uppercase characters come first in the ASCII table. So uppercase characters should come first in this sorted order, and that's why they do there. And in the second example, there are no vowels, so you leave it as the same. So what we basically want to do is, given a string, right? Let's just write out some string. Let's say we have, and we'll kind of write out characters, and then we'll leave some spacing maybe as well. Let's actually even make a chart, essentially. Yeah, let's do it this way. So we're going to write a string like this, and we're going to have some indices in an array, and I think that'll make it easier to see. So let's just say we have some 10-character string. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are a little small, but that's okay. Okay, and so basically we'll have some indices as well. So we'll have like 0, 1, 2, 3, 4, 5. Did I miss one? No, I didn't. Okay. And let's say for our characters, we'll just have some alternating maybe vowels and consonants, right? So we'll have like, see, we'll have C, D. Let's say we have like G, W, and Z or something. And then for vowels, we'll have vowels here. And let's say for now they're all uppercase, even though it's not really going to matter. Let's say all our vowels will be like A, E, U, U, then we'll have like A or something. Okay, so there we go. So we have some string. So essentially what we want to do is we want to fix the order of all of these characters here, and we want to keep the rest the same, right? And so there's a bunch of like, this is kind of one of these problems that's easy to do, and then it more comes down to like, what are the optimizations? What's the best way to do it? So one of the things we can do is we can take every single vowel. So let's say we have these vowels, right? So we can take a vowel, we can put them all together, right? In some like A, E, U, U, A, and then you can just sort this. And I'm actually not sure how uppercase and lowercase characters get sorted, like if uppercase characters come first or second. But either way, you can basically sort. You can just sort this, right? So then you would sort the string, let's say, and you would get something like A, E, like this. And then you would just go through your like you would take your string, you would split it into an array, and then you would go through index by index and just say, okay, let me just go to all the indices that are letters, and I'll also keep track of where I am in my sorted array here of letters, and then I will essentially write down the right letter. So let's say I come to this letter and I'll say, okay, this should be this letter here. So it is. Then I go to this letter and I'll say, this should be this letter here. It's not, so I'll replace it with an A. This should be this letter here. E. This should be this letter here, U, and this should be this letter U. Okay. So that's one way to do it, right? And then you just join this whole thing up and return. So that's one of the ways of doing it, but the problem with this solution is here we're actually going to be doing sorting, which is not ideal because, like, let's say that our string is mostly letters, we're going to have to sort it. And sorting is n log n, so if our string is like a huge amount of letters, we're still going to have to sort it, so that's not going to be the best. So instead, we're not going to do that solution. We are going to do another solution. Let's get rid of all this. So instead of actually like making a string and sorting it, instead we're just going to be taking the counts of every single possible letter. And so what I'm going to actually do is I'm actually going to make a dictionary. We'll call this like counts or something. And we're just going to take, because there are only 10 letters, right? There's A, or I'll just write down all the letters here. So A, E, I, so these are uppercase, O, U, and then the same for lowercase, right? So there's these, and then there are also the lowercase versions, which are these. So let's move this over here, and let's change these to lowercase. So now that we know all these letters, what we're actually going to do now instead is we're going to be traversing our string, and then every time we encounter a letter, we're just going to increment its count. So in this case, let's say all of these letters are actually all uppercase. So for example, we'll reach an A, we'll say count 1 and so on, right? So how many A's are there? There are 2 A's, there is 1 E, there are no I's, there are no O's either, and there are 2 U's, I believe. Okay, so this is our thing. Doesn't really matter, right? So you have something like this, and then you can initialize the rest of them. I'm actually going to initialize the rest of them to be 0, but you can do, it doesn't really matter. So then what you do is we're going to do the same kind of thing, except instead of traversing, so there's a few ways of doing this, right? You can traverse through the letters, and you can, what we're going to do is we know like A's, like we know this is the order that has to happen, right? So we're just going to keep track of some string of the order of keys. So we'll have some string that's like literally this, right? A, E, I, O, U, A, E, I, O, U, and then A, E, I, O, U. And then we're just going to say like, okay, we'll have some letter that we're currently on, and we're going to stay on that letter until the count of that letter is 0. So let's make this a little bit bigger. So we'll start at like this letter, and we'll check, is the count 0? No, it's not. So then we're going to go through this string in order, and we're going to try to find characters that are vowels, and we're going to replace them with A's until we run out of A's. So what's that going to look like? Well, we're going to go over here. We're going to say, okay, this is a vowel. Let's replace that with an A, and let's decrement the count over here to an A. Now, obviously, this was an A already, but it's irrelevant. We just care if it's a vowel. So we'll replace the decrement the count there. Now we hit another vowel, replace it with an A, and decrement the count. Now we're going to say we have no more A's. We have 0 A's. So let's go to the next letter. So we're at an E now. We have E's. Let's keep going down where we were at. Okay, we'll replace this with an E. And let's decrement E's. We have no more E's. Then we have no I's, so we're going to skip the I's. We have no O's. We're going to skip the O's. Now we have U's. And then we will just basically go to this, replace it with a U, and go to this and replace it with a U. And now we have no more U's. And then once we run out of every letter, or if we don't have any of these, once we run out of every letter, we're basically guaranteed to have the string we want, right? Because once we run out of every letter, assuming we did our counts correctly, that means that we have no more vowels to look through. So this is going to be faster by keeping the counts and going through the counts instead of going through the array. Because let's say, what if your word was like AA and then like a million or a billion or whatever consonants? We would be able to end this right away because we would stop before going to the end. But it doesn't really matter, right? You can do whatever you want. But essentially, the reason this is faster is because we don't have to sort our letters now. We just keep track of the count of each one, and there's only 10 different letters. So we just keep track of the count of all of them, and then at every single index, we just write down, okay, what letter are we on? If we have these have to come first. So this is a very good algorithm when your letters or the things you're sorting has a very small amount. So it's kind of like a bucket sort where you're essentially putting all your things into buckets, and we know all of our keys exactly, right? When our key count is very low and we know them exactly, this is like the perfect algorithm here. Because why would we sort, a million letters that there's only 5 of? We can just keep the counts and easily know what goes before what using these buckets. So just to recap, as our number of keys is small, this bucket sort is great. So keys is small, and like total items is big, right? Like this array can be like 10 to the 5th or something. So this is perfect. As keys increases and total items is small, then just do normal sort. Because let's say for a really easy example, let's say we have an array of 10 letters. And let's say we don't only have these letters, we can have like just any character ever made. Let's say there's like a million of them, I don't know. Then we would have a million buckets, but we'd only have 10 letters. So why would we store it like that? It would be much better to just do a normal sort. So that's kind of like the trade-offs here, where you have less keys or more keys and the length of your actual input. So this is what we're going to be doing. We're going to have accounts, and we're going to go through our letters and just simply write down, since we know like what letters have to be first, we'll just keep putting in the letters that have to be first if we have them, and if we don't, we'll just keep going to the next one. And that's kind of the idea behind this one. And we don't sort, so it's going to be faster, and it's going to be an in-place algorithm because we are just going to make an array of result and modify input there directly. And this dictionary of counts is O1 because there's only 10 letters. So that's the other upside. Okay. So now we can code it up. So we're going to have the result array. So we're basically going to just split S here. So we'll just say like char for char in S. For some reason, when I was doing split, it wasn't working. I'm not really sure. I think I was just doing something stupid, but I was trying to split on an empty character. But for some reason, I had some errors. Anyway, so we're going to have our vowels, and our vowels, we're going to write these in sorted order. So the sorted order is A, E, I, O, U, and then lowercase A, E, I, O, U, right? Because in the ASCII table, as I showed earlier, the uppercase actually comes first. Okay, now we'll have V, which is the length of the vowels. And we're going to make this count dictionary of the count of every letter. So we can just do a dictionary comprehension there. So we'll just say, first, what we actually want to do is we want to initialize it all to be 0. You can make a default dict, I guess, but I'll just initialize it. So I'll just say char with a value of 0 for char in vowels, because I want to quickly check if my character is a vowel or a consonant, and I'm going to use the keys in here. So we're going to make a dictionary of every single one of these vowels with a count of 0. Now let's go through the characters in S. So if char in counts, let's counts char plus equals 1. In fact, I guess we could probably make like a dictionary comprehension for that as well, but whatever, it's fine. Okay, so now we have all of our counts, and now what we have to do is we have to actually go through all of these letters. So we're actually going to, what we're going to do is we're going to have an index in S, and instead of looping through S, we're actually just going to loop through characters in our counts. And we're going to say, let's just keep using that character until it's 0, and then let's go to the next character. And when we loop through every character, we're guaranteed to have our output string. So we'll say for letter count in counts.items. And so for items, the way it works is it's key value pairs. So it would be something like if A had a count of 5, you would have a pair of A and 5. So we can get the letter and the count. And essentially what we want to do is we want to say while the count is non-zero, so while count is greater than 0, let's keep trying to add more letters. So if result I in counts, otherwise like if result I is in counts, that means it's a vowel. So we're going to replace it with the current letter we're on. So we'll say result I equals letter, and we're going to decrement the count of the letter. We're not actually going to decrement it in the dictionary, but it doesn't really matter. So our dictionary will stay with our full counts, but it doesn't really affect the algorithm. And then what we need to do here is we need to just increment the index regardless, right? If it's a vowel or a consonant, we need to go to the next thing in the result, the next letter. So now our result should be an array of all the letters correctly put in, right? We went through all of our letters, we put them in where the vowels need to be. So now our result should be correct. So now we just need to turn it into a string. So we'll just join it up. Let's take a look. Okay, looks good. Submit it. And you can see very efficient solution because we are not sorting. So definitely going to be better. So now let's go through the time and space. So for the time, we are looping through every character. So that's O of n. This vowels is O of 1. This is O of 1. This is O of 1. Only 10 vowels. This is O of n. We are going through all the characters. And then this is worst case O of n as well. We would have to go through every single character. So basically O of n. And for the space, it is O of 1 because we create this result array, but then we're just modifying in place, right? We create a results array for the thing we're going to be returning, and we don't count output in our space. Vowels is only 10 characters, and then these counts are only 10 characters, so that's O of 1. So that's why when you have these like really small, only like lowercase English alphabet characters, this is only going to be 10 characters. So that's why this is O of 1, this counts, and this vowels is O of 1, and result is part of the output, so we don't count that. So that's going to be all for this one. Hopefully you enjoyed it. This is more of a problem of not can you do it, but can you do it in the best way. So kind of good practice there. And if you did like the video, please like the video and please subscribe to the channel. And I'll see you in the next one. Thanks for watching.